Hello guys, my name is Phil once again, and this video tutorial I'm going to teach you about linked list. Okay, before we directly start discussion on linked lists, let's have a quick review on pointers and memory management. What are pointers in C or C++? Shortly, pointers are variables used to store an address of another variable. For example, int num1 is equal to 100. Int ptr1, this is a pointer variable. If you assign it num1, then it stores not this value but the address of this variable. Let's see it in table. The two variables are num1 and ptr1. Num1 has stored 100. Once you have assigned ptr1 to be equal to num1, it means ptr1 is storing 1001, which is the address of num1. The top values are address of this piece of memory. So this address stores the address of variable num1. What are the advantages by using pointers? The advantages are you can use pointer to return a multiple value from function. You can use pointer to access any memory location. It improves the performance, reduces the code. You can use it for dynamic memory allocation and deallocation, used in arrays, functions, and structures. The two symbols. The first one is called address of operator or address operator, and so on in direction operator. This address operator determines the address of a variable, and this indirection operator accesses the value as the address. For example, int n is equal to 50. Int asterisk p. P is the pointer variable. This is the way you declare a pointer. This stores address of n to p. Cout address of n variable is this one. Cout address of p variable is p. Value of p is p. These are the occasions which helps you to check what you got so far. What is a pointer? What is the difference between integer and integer pointer declaration? List at least 3 advantages of a pointer. Asterisk is a symbol that determines the address of a variable. True or false? You have to answer these questions. Memory management. Memory management is a way which helps you to handle requests for storage and release of storage, or to allocate and deallocate memories in most effective manner. What do we mean by memory or store? It is required in computer to store programs. Programs, in a sense, can be functional data. Data used by the variables in a program is loaded into memory for fast access. We can say that memory is made up of a very large number of cells where each cell is capable of storing one bit. One bit means either 0 or 1. The cells may be organized as a set of additional words, each word storing a sequence of bits. This additional memory cores should be managed effectively to increase its utilization. That is, memory management is to handle the storage of program data. What do we mean? Dynamic memory management. Memory can be managed statically or dynamically. Dynamically is simply using pointers. Statically is if you are using arrays. So this dynamic memory management helps you to optimize the use of storage spaces by allowing us to allocate additional memory space or to release unwanted space at runtime, which makes it more flexible. There are four basic dynamic memory allocation and deallocation functions, like malloc to allocate a single block of memory, calloc allocates multiple blocks of memory, realloc to reallocate or to change the memory occupied by malloc and calloc functions. Free is another function which helps you to deallocate a memory allocated to variables. Check out your knowledge so far, what you have got. Why is memory management needed? What is the reason behind the computer program requirement of memory? Dash is a function used to allocate multiple blocks of request memory. malloc, calloc, realloc, or all of the above. Does C++ support all C dynamic memory management techniques? True or false? List two new features of C++ in dynamic memory management techniques. Okay, this is the main concept in chapter 3, linked list. If the memory is allocated for variables during compilation time, then it is fixed. It cannot be changed. You cannot increase it or decrease it. For example, if you declare an array which can store 100 elements, the storage space allocated to these 100 elements is reserved. You cannot use it for another purpose. If you only store half of these elements, 50 elements, then a storage space allocated for the remaining 50 elements will be wasted. So you cannot increase or decrease the size. So here we have to adopt an alternative strategy to allocate memory only when it is required. That is called linked list. This linked list provides you a more flexible storage system, and it does not require the use of arrays. It uses pointers. What is linked list? Linked list is one of the linear data structure which contains collection of sequentially designed elements, sometimes called nodes, linked to one another by means of pointers. Each node has two parts, info part and address part. The address part stores the address of the next node. Look at here. We have a pointer pointing to a node. This node has two parts. This is the address part and so on the info part. The info part stores the data itself, and here the link field or the address field stores the address of the next node. Here it stores null because there is no next node in the linked list. So 50 is the data and the next address is null because there is no another in the list. So this pointer is the start pointer, which always points to the first node in the list. This is the linked list representation in memory. You see, this is the value stored in the star pointer. This stores the address of this node. The address of this node is 0x80017. So the star pointer is storing the address of the first node. The first node has some actual data value and address of the next node. The address of the next node is 0x80010 and it is stored in the link address or in the link field of this node. Same is true. This node has stores the address of this node. The last node link field has stored null pointer. So in a linked list we have two pointers. The star pointer, which stores the address of the first node, and null pointer, which points to nothing. This indicates that the node which stores null pointer is the last node in the linked list. How do we represent it in memory? We have to define a structure. Struct the name of the node. Let's say it's node. N is capital, O, D, E, R, small letters. Then here we have to specify two elements: int data, which is the info field, and struct node asterisk next, or you can use link. This is the pointer which stores the address of the next node. Here we need to define an identifier which helps you to create an instance of this node. Type div struct node asterisk node. What are the advantages of using linked list? It is a dynamic data structure that is it can help you to grow or shrink the storage space needed during the execution of a program. Efficient memory utilization. In linked list representation, memory is not pre-allocated. Memories are always allocated whenever it is required. If it is not required, you can deallocate the storage space which is allocated. So you can increase it or decrease it. You can grow the storage space or shrink it at execution time, at runtime. Insertion and deletion are easier and efficient. More complex applications can be implemented with linked lists. What about the disadvantages? It needs more memory. To store an integer number, a node with integer data and address field is allocated. There is more space required here. The storage needed for the pointers is additional memory required. So this can be considered as a disadvantage. Access to an arbitrary data item is a little bit difficult, cumbersome, and also time consuming. That is because you cannot access data items randomly. You can access it uh, sequentially by moving from the beginning until the data item that you are looking for. Then you have to make traversals movements. That makes it a little bit difficult. What are the basic operations, primitive operations which can be performed on linked lists? You can create nodes, you can insert nodes at the beginning, at the end, at any position. You can delete from the beginning, from the end, or from the middle positions. You can traverse or display nodes of linked lists. You can search a data item. You can concatenate two different linked lists together. These are the basic operations which can be performed for linked lists. Uh, Based on arrangement of data items in linked lists are categorized in three divisions: singly linked list, doubly linked list, and circular linked list. All the nodes in a single linked list are arranged sequentially by linking with a pointer. We have a subpointer pointing to the first node pointing to next node, the last node is determined by storing that pointer in its field and in its link field. What about double? Double is the same as singly linked list, except it helps you to navigate backward, not only forward but also backward. In single linked list, you just can only move forward. It has only a next link address. In double linked list, all nodes are linked together by multiple links which help in accessing both the successor and predecessor nodes for any arbitrary node within the list. So the difference between single linked list and double linked list is in single linked list there is only one pointer which helps you to move forward, whereas in double linked list there are two pointers, left pointer and right pointer, or next pointer and previous pointers, which helps you to move forward and in backward directions. So this is how you can represent double linked list. Circular linked list, as its name implies, the nodes in circular linked list are arranged in circular fashion, in circular arrangement. In this linked list, it doesn't have any beginning end. There is no end. Any node can be the beginning, any node can be the end. A single linked list can be made a circular linked list by simply storing the address of the very first node in the link field of the last node. Both single linked list and double linked list can be made circular linked lists. What is linked list? How does it work? How can we represent a linked list in memory? What are the pros and cons of using linked lists? Explain some of the primitive operations of all the linked lists. How many types of linked lists do we have? What are they? Check it out. Thank you. Okay. So far we have seen the basic concepts of linked list. We have discussed what are the three uh, types of linked lists. Now we are going to discuss the types of linked lists one by one. Okay, single linked list. Uh, you know, in static implementation or in static memory management, is difficult to increase or decrease the memory uh, space needed for a program or allocated for a variable. So we need to have an alternative strategy which solves uh, this problem. It should be dynamic. Dynamically simply using pointers in a linked list or single linked list. Uh, in a single linked list, all the nodes are arranged sequentially by linking to one another with a pointer. The single linked list helps you to grow or to shrink the storage requirement for a program dynamically, which means at execution time. Uh, the flag shows you how singly linked list works. We have a star pointer which should point to a node. This node has two parts, info part or info field and address field or link field. This link field points to another node. Unfortunately, there is only one node in this linked list. Therefore, its address field is storing null. If you insert 40 at the end, star pointer is pointing to 30, then 30 should point not to null. It should point to the new node, which is 40. Okay. What if you want to insert at the beginning? We have a star pointer and the first node is 30, then 30 is pointing to 40. We want to insert a new node in the middle 10, in the beginning. Create the new node, then let it point to 30, then star pointer should point to the new node 10. This is how you can insert a new node at the beginning. What if you want to insert at the second position? You can insert at any position. Second position means between 10 and 30. We have to create a new node. New node should point to 30. Then the first node should point to the new node. This is how you can insert at the second position. What if you delete the second node? 10 is pointing now to 20. If you remove this one, then 10 should point to 30. 10 is pointing to 30, 30 to 40. Algorithm inserting a node. There are variables which first you need to know, like start is a pointer which points to the first position in the linked list. Data is the info field or the data value which should be stored into this field. Pos is a variable for position where the new node is to be inserted. Temp is a temporary pointer to hold the node address. Size is the current total nodes in the list. So if you want to insert in the third position, then create a new node and let the new node point 40 and 30, 34. This is how you can insert a new node. Let's see the algorithm. To insert at the beginning, first input data, then create a new node. Then the input data value should be assigned to the data field of the new node. If start is equal to null, then new node link should be equal to null. Else, new node link should be to the first node, which is equal to start, and the new node should be the first node in the linked list. What if you want to insert at the end? Most of the time, the first statement is input statement. Create the new node, then assign data to the data field of the new node. Here, we are saying end. If it is to be inserted at the end, then its next address, its link address should be equal to null. This indicates that the new node is inserted at the last position. If start equal to null, start should be equal to new node. Else, we have to move to the last node. Therefore, temp should be equal to start. We have to start from the beginning, then we have to find the last position or the last node. Therefore, temp should be equal to start. Temp is now pointing to the start, to the starting node or to the first node. While temp next is equal to null, then temp should move to next. This is to find the last node. Once you find the last node, temp next should be equal to new, then exit. This one is to insert a new node at any specified position between the beginning and the end. First, input two values, data value and position. Initialize temp is equal to start and k is equal to 1 if pause is equal to 0 and pause is greater than size plus 1, display invalid position. Else, if start is equal to null or pause is equal to 1, insert at the beginning. This is if start is equal to null or pause is equal to 1, we are inserting at the beginning. So we have to call insert at the beginning. Insert at the beginning is this algorithm. Repeat step 3 while k is less than pause minus 1 and temp next is not equal to null. This helps you to find until the node before the last node. Then temp should be equal to temp next then k plus plus. Create a new node. Data value should be assigned to the data field of the new node. The new node next should be equal to temp next should be equal to new node, then exit. Algorithm for deleting a node. Suppose start is the first position in the linked list. Let data be allowed to be deleted. Temp hold a temporary pointer to all the node addresses. See? Let's say we have these elements. If you want to delete 34, position 3, then 30 should point to 40. First, assign 30 to temp, then 34 to hold, then let temp point to 40, finally release hold. Input data to be deleted. If start data is equal to data, which means if the data you inserted is the data value of the first node, then temp should be equal to start should be equal to start next. Set phrase then now temp which is deleted then exit. If you are deleting from the middle, hold should be equal to start, while hold next is equal to null. If hold next data is equal to data, then temp should be equal to hold next should be equal to temp next. Set freezer now temp which is deleted then exit. B hold should be equal to hold next, it should move forward, otherwise display data not found, finally exit. Algorithm for searching a node. Suppose start is a pointer which stores the address of the first node in the linked list, and that has the information to be searched. After searching, if the data is found, pos will contain the corresponding position in the list. Input data to be searched. Initialize temp to be equal to start of the first node, pos is equal to 1. Repeat step 4, 5, and 6 until temp is equal to null. Temp data is equal to data. Display the data is found at pos, then exit. Temp it should move to the next. Pos should be incremented by 1. If temp is equal to null, display the data is found in the list. Finally exit. To display all nodes, check if start is equal to null. If so, display this message. The list is empty. Otherwise, initialize temp is equal to start. Repeat step 4 and 5 until temp is equal to null. Display temp data. Temp should move to the next and exit. Okay. I have shown how stack is implemented using linked list in my previous video tutorial. I will give you a link in the description below to the implementation of stack using linked list. But now let's discuss how stack is implemented using linked lists. Implementation issue of the stack just before using linked list is illustrated in the following figure. Let's say top is null at the beginning. If you push 10, then top should point to 10. If you push 20, top should point to 20 and 20 to 10. Pop, then 20 should be deleted. Therefore, top should point to 10 instead of to 20. Like this. Algorithm for push operation. Suppose top is a pointer which is pointing towards the topmost element of the stack. Top is null when the stack is empty. Data is the data item to be pushed. Here, input data to be pushed, create a new node data should be equal to data. The new node next should be equal to top, and top should be equal to new node, then exit. Algorithm for pop operation. As I have mentioned before, top is a pointer pointing to the topmost element of the stack. Top is initially null while the stack is empty. Temp is a temporary pointer variable to hold any node address. Data is the information on the node which is just deleted. So in order to delete, first we have to check whether the stack is empty or not. If top is equal to null, this indicates that the stack is empty. Therefore, display this message to the user. Else, temporary pointer should be equal to top or the first node or the topmost element on the stack. Then display the copied element. top data. Top should be equal to top next. Then you have to isolate the node to be deleted by assigning null to its next address, which means you are disconnecting it from the remaining elements of the stack. Then free up the temp pointer, then exit queue using linked list. This one is also implemented in C++. I'm gonna give you the link in the description below. Here we are going to see only the concept. Queue is a first in, first out data structure, which is FIFO. We will see how we can implement queue using linked lists. Okay, now let's see how queue is implemented using linked list graphically. In queue there are two pointers, front and rear pointer. Front pointing to the first node and rear pointing to the last node. Initially both are null. If you try to push any node, then the new node is 10. Front should point to 10 and rear should point to 10. Both are pointing to the same element, which means that there is only one node in the list. If you try to push another element, 20, front is pointing to 10, then the new element should be pushed at the end, because rear end is where new elements or new nodes are inserted, and front end is from which elements are deleted. So 20 is pushed after 10 and rear should point now to 20. If you try to pop, 10 should be popped, front should point now to 20 and rear should point to 20. Algorithm for pushing an element to a queue. We need two pointers, rear and front pointers. Rear is a pointer in queue where the new elements are added, and front is a pointer which is pointing to the queue where the elements are popped for data is an element to be pushed. Therefore, we have to input the data first, then create a new node, assign the data to the data field of the new node, and null to the next address of the new node, because it's gonna be pushed at the rear end. If rear is not equal to null, then rear next should be new node and rear should point to the new node. Finally, exit. To perform pop, we need an algorithm. Like, first we have to check whether front is equal to null or not. This checks whether the queue is empty or not. If it is equal to null, it means the queue is empty. Therefore, display this one and then exit. Else, display the popped element is front data. If front is not equal to rear, front should be equal to front next. Else, front should be equal to null. If front is equal to rear, it means there was only one element. Therefore, front should be equal to null. Then exit. Doubly linked list. Double linked list is one in which all nodes are linked together by two links, the one for a previous and the other one for the next nodes. Therefore, it has three fields, like previous pointer, data field, and next pointer field. Left pointer will point to the left side. Y pointer will point to the right side of the node. That will store the actual information of the node. We have a start pointer pointing to 10 and 10 pointing to 20, and 20 is also pointing back to 10. This is y direction. Here 20 is pointing 30 and 30 should point to 20. The last field of 30 should be equal to null to indicate that there is no another node in the double linked list. And so is the memory representation of double linked list. Here you see the subpointer is storing the address of this node, address of 10, which is 80019. It's stored on the subpointer. And the right pointer, the next pointer of 10 is storing the address of 20. 20 is storing the address of 10 in its left pointer, and the address of 30 in its right pointer. 30 is storing the address of 20 in its left pointer and null in its right pointer to indicate that it is the last node in the list. This is how we can represent in memory. You have to define a structure. Let's say the name is node. It has 3 elements: the previous pointer and the previous pointer, the data field, and the next pointer. This is to declare an identifier which helps you to create an instance of this node. All the operations performed on single linked list can also be performed on double linked list. Hence the creation, deletion, search, concatenation, and so on. Traversal. This shows the insertion and deletion of a node in the double linked list. Start is pointing to 20, insert 30, 20 should point to 30 and 30 should point to 20. If you insert at the beginning, 10 is pointing to 20, 20 pointing to 10, 30, 20 pointing to 30, 30 pointing to 20. If you delete an element from the second position, 20 should point to 30 and 30 should point to 10. Algorithm for inserting a node. To insert a node between 10 and 30, we have to create the new node first, then create a link from the new node to 30, from 20 to 30, then from 30 to 20. Again, from 10 to 20, and from 20 to 10. This is how you can insert. Here we need variables like start pointer, data, pause, and temps. Algorithm for inserting a node at the beginning. Input the data, create a new node. Then at the beginning, so its previous pointer should point to null. Info should be equal to data, and its next should be equal to start, and start previous should be equal to new node, and start should be new node. To create a list for inserting a node at the end, first input data, then temp should be equal to start, create the new node info should be equal to data. We are inserting at the end, therefore its next pointer should point to null. If start is equal to null, new node previous should be equal to null, start previous should be equal to new node, start should be equal to new node. Else move to the last node, while temp next is not equal to null, then move next. Temp next should be equal to new node, and new node previous should be equal to temp, then exit. To insert at any position, input data and pause. Then initialize temp to be equal to start from the first node, I should be equal to 0. Repeat step 4 and 5 until I is equal to pos minus 1. Temp should be equal to temp next. If temp is equal to null, display the are less than pos nodes in the list. So let's create a new node. New info should be equal to data. Temp next previous should be equal to new node. New node next should be equal to temp next. New node previous should be equal to temp. Temp next should be equal to new node. To delete, simply let's say you want to delete the element in the second position 20, so assign it to temporary pointer, then create a link from 30 to 10 and from 10 to 30. Now you can delete the temporary pointer which hold this 20 temporarily. This is the algorithm to delete. Input the data to be deleted. Initialize temp is equal to hold is equal to nil. If start info is equal to data, which means if the data to be deleted is the first node, then hold should be equal to start, search should move to the next, start previous should be equal to nil, then free hold return. Otherwise, initialize temp is equal to start. You have to begin from the first node. Then repeat step 6 and 7 until temp next is equal to null, which means if the element to be deleted is in the middle, in between the beginning and the end. If temp next info is equal to data, hold should be equal to temp next. Temp next should be equal to hold next previous should be equal to temp, then fair hold pointer, then exit. Otherwise, the node to be deleted is the last one. Therefore, temp is equal to temp next. If temp next info is equal to data, hold temp next, then fair hold temp next should be equal to none, then inside. Circular linked list. As its name implies circular, the elements are in a circular fashion. They are arranged in a circular fashion. Circular linked list has no beginning and no end. Single linked list and double linked list can be made a circular linked list. Single linked list can be made a circular linked list by simply storing the address of the very first node in the link field of the last node. Next. This is single linked list. To make it circular, this should store address of 10 instead of 9. See, instead of null pointer 40 should store the address of 10. That is how it should work. How you can make single linked list, circular linked list. Algorithm for circular single linked list is input data and pos, initialize k equals 0 and temp is equal to last link. Here in circular we use last pointer only. Repeat step 4 and 5 until k is less than pos minus 1. Temp should be equal to temp link. If temp is equal to null, display there are less than pos nodes in the list, then exact. 6. Create a new node. New node info should be equal to data. New node link is equal to temp link. Temp link should be equal to new node. If temp is equal to last should be equal to new node, then exact. This is for deletion. If data, input data, then if last is equal to display list underflow or the list is empty, then exact. Else last link is equal to last if the data to be deleted is in the last pointer, then hold last is equal to null, delete hold exact. Else temp last link temp should be equal to last link. If temp info is equal to data, hold temp last link should be equal to queue link, delete, hold, then exit. Instead of queue, should be hold the link. Repeat step 7 and 8 until temp link is equal to null. If temp link info is equal to data, hold should be equal to temp link should be equal to hold link, delete, so hold, exit. Temp should be equal to temp link. If temp link info is equal to data, hold should be equal to temp link should be equal to last link, delete, hold, then exit. To delete a node from the circular linked list, it's almost the same as the previous one. Display all the nodes. If last is equal to null, display list is empty. Then exit. Otherwise, temp should be equal to last link, while temp not equal to last, display temp info, temp should be equal to temp link. Then finally display last info, exit. Circular doubly linked list has both the success pointer and predecessor pointer in circular manner. See? But here there should be a link from 20 to 10, from 30 to 20, from 40 to 30. Okay, that is a correction. Algorithm for creating circular list: inputs the data, initialize list to be equal to null, create new node info should be equal to data. If last is equal to null, last should be equal to new node link should be equal to last, else new node link should be equal to last link should be equal to new node, last should be equal to new node, then exit. To insert as a beginning input data, create a new node info should be equal to data, new node link should be equal to last link, and last link should be equal to the new node. Algorithm for inserting a node at any position is: input data and pause, initialize temp is equal to last, next, or link, then I should be equal to 0, repeat step 4 and 5 until I is equal to pause minus 1, temp should be equal to temp. Next, if temp is equal to last link, display 0 less than pause in the list, then exit. Otherwise, create a new node next should be equal to temp next, new node info should be equal to data, temp next should be equal to new node. If temp is equal to last should be equal to temp, this temp. Then exit. Priority queue. Priority queue is a queue where each element is assigned a priority. In priority queue, the elements are deleted and processed by following rules. An element of high priority is processed before any element of low priority. Two elements with the same priority are processed according to the order in which they were inserted to the queue. Example: consider a manager who is in a process of checking and approving files in a first come first served basis. The FIFO. In between, if any urgent file with a high priority comes, he will process the urgent file next and continue with other low urgent files. That is the concept of priority queue. You see here we have data 10, 14, 12, 16, 17, and this is their priority. this is the graph which shows how push operations on periodic queues works. Not only push but also pop operations. That's all for chapter 3 about linked lists. If you have any question, you can comment down below on the comment section. Thank you for watching.